I'm happy to talk to you today about the science of fiber. Dietary fiber is the portion of plant-derived food that cannot be completely broken down by human digestive enzymes. However, it gets more specific than that. For more than 100 years, scientists from different countries have debated the definition of fiber. In fact, some countries still do not have an official definition of fiber. This is because what we might consider to be fiber can be classified according to different parameters, such as being resistant to hydrolysis by digestive enzymes, or part of a carbohydrate obtained when using AOAC method 985.29, or that part of a carbohydrate obtained analytically by AOAC method 985.29 and inulin and illegal fructose, or finally, the edible part of plants or analogous carbohydrates that are resistant to digestion and absorption in the small intestine with complete or partial fermentation in the large intestine. These definitions may seem confusing and even insignificant, but they derive from specific research that has been conducted on the origin of fiber, the way humans respond metabolically to fiber, and the health benefits that we observe and expect from consuming fiber. For our purposes, we will stick with the definition of fiber being the portion of plant-derived food that cannot be completely broken down by human digestive enzymes. Now that we have a working definition of what we consider dietary fiber to be, let's discuss different types of fiber. Fiber can be classified as either soluble or insoluble, depending on whether it is soluble in water or not. Soluble fiber attracts water and turns to gel during digestion. This gelling effect slows digestion. Insoluble fiber adds bulk to the stool and acts like a broom to push food through the stomach and intestines. Aside from classifying fiber as soluble or insoluble, fiber can also be graded according to relative viscosity, gel-forming capabilities, and fermentation rate by the gut microbiota. These other physiologically relevant parameters are a better measure of fiber's role in impacting our health. There are a variety of sources of soluble and insoluble fiber, and there are several key health benefits of both types of fiber that we will review throughout this discussion. When it comes to the sources of fiber, they are plentiful. In fact, it is one of the most abundant components of the Earth's biomass. Some of the common sources of fiber include whole grains, fruits, vegetables, legumes, and nuts. Unfortunately, high degrees of processing and milling commonly removes the dietary fiber and other important nutrients from these otherwise excellent foods. Equally discouraging, many people's diets simply do not contain the amounts of fruits, vegetables, and whole grains that they need to support a healthy diet and the well-being associated with it. There is general agreement with the statements that 1, fiber is good for you, and 2, most people do not consume enough fiber. It is recommended that women consume 25 grams of fiber per day, and that men consume 38 grams of fiber per day. Most people do not come close to consuming this amount of fiber each day. In fact, in the United States, it is estimated that more than 90% of the population falls short of these recommendations, consuming less than half the recommended daily fiber intake. That might be okay if you are satisfied with having less than half the benefits of consuming the recommended amount of fiber each day. I want to talk a little about the importance of consuming adequate fiber each and every day, and then get specific about the health benefits you can expect from doing so. Diets rich in fiber are related to decreased incidence of several diseases and have a positive effect on overall health. The physical effects of fiber provide the metabolic health effects that are commonly associated with fiber consumption. These health effects are achieved in a few specific ways. Recall that insoluble fiber adds bulk to the diet, making one feel full faster and reducing appetite. Also remember that soluble fiber attracts water and turns to gel during digestion, slowing gastric emptying and macronutrient absorption. This soluble fiber gel in the digestive tract during the digestion and absorption processes lowers the variance of postprandial blood sugar levels. In addition, soluble fiber has been demonstrated to increase the rate of bile excretion, thereby reducing total low-density lipoprotein, or LDL cholesterol. That's the bad kind. Furthermore, production of the specific short-chain fatty acid propionate, a byproduct of fiber fermentation in the intestines, has been shown to downregulate cholesterol synthesis. Reduced total and LDL cholesterol levels correlate with reduced risk of heart disease. About heart health, fiber positively affects blood pressure, another factor associated with metabolic health. In all, individuals with high intakes of dietary fiber appear to be at significantly lower risk for developing coronary heart disease, stroke, hypertension, diabetes, obesity, and certain gastrointestinal diseases. Quality fiber is truly a superhero nutrient that we cannot afford to ignore. A high fiber diet is a common recommendation of most diabetes and nutritional associations, and it is one that I am echoing for each of you as well. Dietary fiber consumption can regulate food intake and thus support either weight loss or weight maintenance, whichever the case may be. In fact, fiber supplementation in obese individuals significantly enhances weight loss. Subjects consuming high dietary fiber diets demonstrated increased post-meal satiety and decreased subsequent hunger. Several observational studies have shown an inverse relationship between the amount of fiber consumed in the diet and body weight. In other words, high fiber diets are supportive of lower body weights, and this is accomplished by post-meal satiety, better insulin sensitivity, and delayed macronutrient absorption. To highlight the science of fiber discussion today, I want to describe some of the specific mechanisms by which fiber provides so many health benefits. Dietary fiber consumption affects the secretion of various gut hormones that act as satiety factors, namely CCK, GLP-1, GIP, and adiponectin. CCK, known as cholecystokinin, is a gut hormone that acts as a satiety signal. GLP-1, also called glucagon-like peptide 1, and GIP, known as glucose-dependent insulinotropic polypeptide, are both peptide hormones that regulate insulin secretion. Finally, adiponectin, a protein hormone involved in several metabolic processes, including glucose regulation and fatty acid oxidation, can act as a peripheral starvation signal, promoting the storage of triglycerides, preferentially in adipose tissue. This last hormone, adiponectin, has been shown to increase 60 to 115% in response to dietary fiber supplementation, thereby improving both glucose response and fatty acid oxidation. Interestingly, a couple of different G-protein coupled receptors in the gut are a direct target of short-chain fatty acids, and their downstream effect via receptor activation is to increase leptin production, which is an anorexigenic hormone. Anorexigenic means loss of appetite. In other words, short-chain fatty acid production from fiber fermentation in the gut helps to control your hunger and appetite. Increased intake of dietary fiber is inversely associated with markers of insulin resistance, and this is measured as lower fasting glucose and glycated hemoglobin, or HbA1c, both of these being metabolic health markers commonly measured in the blood. This improved insulin sensitivity and reduced fasting glucose is associated with reduced diabetes risk for those consuming high dietary fiber diets. A final word on fiber and the microbiome. The human microbiome is a fascinating complex of microbiota that reside on or within human tissues. When it comes to dietary fiber, we are most interested in how the fibers we eat benefit the microbiome in our digestive tract. which benefits many other areas of our bodies. As we reviewed at the beginning, dietary fibers are those portions of plants that cannot be completely broken down by human digestive enzymes. This is where the microbiome comes into play. The specific chemical glycosidic linkages found in dietary fibers, alpha-1,4, beta-1,4, and mixed beta-1,3 and beta-1,4, are recognized by the microorganisms in our gut. These organisms are able to digest these fibers and produce beneficial metabolites that can act as secondary messengers to support our immune and brain health. Keeping them thriving through regular, adequate consumption of dietary fiber not only benefits our digestive tract, it benefits our entire body. Dietary components remaining undigested at the end of the small intestine are routinely fermented within the long intestine by the microbiome of our gut. A fascinating study in this area demonstrated that the transfer of lean microbiota from lean organisms to obese organisms altered fat gain, even when controlling for energy intake. In other words, supporting our microbiome with the adequate regular consumption of dietary fiber can shift microbiota populations toward the lean microbiota and thereby support insulin sensitivity, reduced inflammation, and overall better metabolic health. We have discussed sources of fiber, types of fiber, and the role of fiber in contributing to your health. We've reviewed specific mechanisms by which fiber not only maintains, but improves your health. I hope you learned something new and that you can experience these health benefits by consuming adequate amounts of fiber daily.